In section 3.2, we are looking at the relationship between probability and odds. You'll recall from the last section that probability calculates the chance of an event occurring. You'll also recall that this notation, P at A, represents P, the probability of event A occurring. And that probability is normally expressed as a fraction, where the numerator represents the number of favorable outcomes and the denominator represents the total number of outcomes. For example, in this class, the probability that a student is wearing glasses is, well, we don't have a class in front of us, so I'm going to just make up some data. I'm going to say that the number of students in the class is 19, and I'm going to say that the number of students in the class who are wearing glasses is 11. That would mean that the probability that a student wears glasses would be favorable, 11 out of total, 19. What if we were asked for the probability that a student is not wearing glasses? Which seems like an odd thing to ask, but it's going to help us in this section. The probability of not wearing glasses. Well, the total number of students is still going to be 19. But what we have to figure out is the opposite of wearing glasses. Well, there's 19 total students. 11 of them are wearing glasses, which means 8 of them are not. So our probability here becomes 8 out of 19. The probability of wearing glasses was 11 out of 19. The probability of not wearing glasses was 8 out of 19. Let's talk about odds. Odds is a different way to express a level of confidence about the occurrence of an event. Odds also calculates the chance of an event occurring, but it uses different values and it expresses those values in a different way. We have two kinds of odds. The first kind of odds we're going to talk about are odds in favor. Odds in favor are the ratios of the number of favorable outcomes compared to the number of unfavorable outcomes. So that's different than probability in two ways. First of all, odds is expressed as a ratio. That's different than probability. Probability was either a fraction or a decimal or a percent. Odds are always a ratio. Also, odds compares favorable to unfavorable outcomes, which is different than probability, which compares favorable to total. So going back here, in the above scenario, odds in favor that a student in class wears glasses compares the favorable outcomes, which for that one was 11, compared to the unfavorable outcome, which would be 8. So favorable in this case would be wearing glasses. Unfavorable would be not wearing glasses. 11 to 8. Let's talk about odds against. Odds against are the ratios of the number of unfavorable outcomes to the number of favorable outcomes. Odds against is just the opposite in odds in favor. It compares unfavorable to favorable. So in this scenario, odds against wearing glasses, we would compare not wearing glasses to wearing glasses. So our numbers would be 8 to 11. We can see that odds in favor and odds against are very similar, but they are opposites of each other. Odds in favor compares favorable to unfavorable. Odds against compares unfavorable to favorable. Let's summarize that on the next page. If the odds in favor of event A occurring are m to n, then the odds against event A occurring are n to m, which is what we just talked about in the previous page. Odds in favor compares favorable to unfavorable. So m represents favorable outcomes, n represents the number of unfavorable outcomes. Odds against event A is just the opposite. It compares unfavorable to favorable. So we can easily convert from odds in favor to odds against and vice versa just by switching the numbers in the ratio. What about the relationship between odds and probability? Well, the probability of event A would be m, which represents the number of favorable events, over m plus n, which is the total number of events. So m plus n must equal the total. You'll notice that odds does not use a total. Odds only compares favorable to unfavorable. Probability does require a total. And more importantly, the number of favorable outcomes plus the number of unfavorable outcomes equals the number of total outcomes. That's going to be really important to us when we are converting from odds to probabilities, which is going to be one of the very important things that you do in this section. Also, we should note, and we actually talked about this above when we talked about the people wearing glasses versus the people not wearing glasses. If we want to convert from probability to odds, we have to know this. The number of unfavorable is equal to the number of total outcomes minus the number of favorable outcomes. So that's really going to help us when we convert from probability to odds, which is another one of the tasks that you're going to have to do in this section. Okay, so odds just compare favorable and unfavorable. Probability compares favorable and total, and we must be able to convert between the two. Let's have a look at that little example there. Let's say we have a different class, and in that class, odds against a student wearing glasses is 17 to 7, which means we are comparing unfavorable to favorable, or specifically in this class, 17 would represent not wearing glasses, and 7 would represent wearing glasses. We want to know the probability that a student wears glasses. Okay, so for this class, the probability that a student wears glasses, we would take our favorable value, which is 7, and we would divide it by the total. How do we get the total? Because again, odds doesn't use a total. We would take our unfavorable and add the favorable, add those two numbers. And so the probability that a student wears glasses in this class would be 7 out of 24. Let's apply what we have talked about here in some examples. Example number 1. Research shows that 1 out of every 67 pregnancies results in an expectant mother having a multiple birth, so having twins or triplets. Our questions are, what is the probability that a pregnancy does not result in multiple births? And then what are the odds against a mother having multiple birth? Let's use this little box on the side to talk about what we have and what we want. So what info are we given? Well, 1 out of 67 pregnancies results in having a multiple birth. So what we're given there is we are given the probability of having a multiple birth is 1 out of 67. What am I supposed to answer? So what do we want to know? Well, we want to know two things. We want to know the probability of not a multiple, which means we have to know how many pregnancies do not result in having a multiple. And then we also want to know the odds against having a multiple. So we have to know what odds against means, and we have to know what numbers represents our favorable and unfavorable outcomes. Okay, let's talk about the first part. The probability of not having a multiple is just the opposite of having a multiple. So our total is still going to stay as 67, but to find the opposite of having a multiple, we're going to take the total and subtract 1, subtract that favorable outcome, which would give us 66. So if the probability of having a multiple is 1 out of 67, the probability of not having a multiple will be 66 out of 67. Let's talk about odds against. Odds against compares unfavorable to favorable. More specifically for this question, we are comparing not having a multiple to having a multiple. How many pregnancies result in a multiple? That was 1. How many pregnancies result in not having a multiple? That was 66. So remember, odds does not use the total, just the favorable versus the unfavorable, or in this case, unfavorable, favorable versus favorable. And there are your odds. Let's look at our next example. A computer randomly selects a university student's name from the university database to award a $100 gift certificate to the bookstore. The odds against the selected student being a first-year student are 37 to 12. Determine the probability to the nearest tenth of a percentage that the randomly selected university student will be a first year. Okay, what info are we given? We are given odds against, which means we are given the unfavorable outcomes versus the favorable outcomes. What are we supposed to answer? What are we supposed to find? We are supposed to find the probability that it is a first year that is chosen. What do we need to answer that? We need to know our number of favorable outcomes. We need to know our number of total outcomes. Okay, so let's talk about what we have. We have odds against. We have 37 to 12. So favorable outcomes here is that a first-year student is chosen. That means our unfavorable is it's not a first year that's chosen. We want to find the probability that it is a first-year student chosen. So probability means we want to find our favorable over total. Favorable outcomes comes straight from that odd statement there. 12 total. We take our unfavorable outcomes and add those favorable outcomes. So our probability here is 12 out of 49. Now let's go back and read carefully. This probability we want written to the nearest tenth of a percentage. So what we're going to do is we're going to take that fraction, that 12 out of 49, we're going to convert it to a decimal on our calculators by going 12 divided by 49, and then, so that gives us 0.2449. I'm just going to round to 4 decimal places. And then we take that and multiply it by 100, and we're going to get 24.5%. And there is our probability to the nearest tenth of a percentage. So we went from odds against, unfavorable to favorable, to probability, favorable over total. Let's look at our last example in this section. A hockey game has ended in a tie after an overtime period, so the game must go to a shootout. The coach must decide whether Ellen or Brittany should go first in the shootout. The coach would prefer to use his best scorer first, so he will base his decision on the player's shootout records. Use the information below to determine who should go first. The first thing we need to do is decide who is the best scorer. What does that mean? So we're going to define that first. And what I'm going to say is the person who is the best scorer is the person who has the highest probability of scoring. What that means then is that we are going to have to find the probability that Ellen scores, the probability that Brittany scores, and then we're going to pick the player who has the higher probability. Let's keep in mind that probability is the number of favorable outcomes out of the number of total outcomes. Let's look at Ellen first. The probability that Ellen scores. Let's see what we know about Ellen. We know that she has attempted 13 shots and she has scored on 6 of them. So this would represent her total number of shots. This would represent a favorable outcome. She scored. So Ellen's probability is going to be 6 out of 13. Favorable over total. Let's look at Brittany. Let's look at the probability that Brittany scores. Well, Brittany's information is a little different. For Brittany, we have odds in favor of scoring are 5 to 7. So here's what we know. We know that favorable, which would be scoring, is 5. We know that unfavorable, which would be not scoring, is equal to 7. Because it's odds in favor, the favorable number goes first. So let's start to look to convert this to a probability. Favorable goes in the numerator. The denominator is the total. Total comes from favorable plus unfavorable. So Brittany, her probability is 5 over 12. Now, those probabilities in that form are a little hard to compare because they don't have the same denominator. So what we're going to do is we're going to convert them both to decimals. So for Ellen, we're going to go 6 divided by 13, and I'm going to round that to the nearest hundredth. So Ellen's probability would be 0.46. Brittany's probability, if we take her favorable 5 and divide it by her total 12 and change that to the nearest hundredth, we get 0.42. So we can see that Ellen's probability is higher. So she should go first. And that's what we will answer. So we're going to say Ellen should shoot first. Okay, she has the higher probability. She should shoot first. All right, that is section 3.2, looking at probability and odds.